Alright, today we're going to be talking about Chapter 8, Lesson 8. This is all about solving multi-step equations and inequalities. So when we're solving multi-step equations and inequalities, there's a couple things that we need to keep in mind. One of those things that we want to keep in mind is simplify when possible. So if you look at example 1, for example, here, we have two parts of this equation, two expressions that are equal to each other, this one here and this one here, and they both have the distributive property that would need to be done first. So simplifying that first is going to make it a lot easier. And then, of course, you always want to solve for your variable. That, of course, is always the crucial part. So let's look at example 1 here. It says solve this equation, and then, of course, check your solution. So the first thing that I'm going to want to do here is undo the distributive property. So this area here, we're going to have 6 times b minus 6 times 2. Which happens to be 6b minus 12. On the right side, we have 2 times 2b and 2 times 8, which happens to be 4b plus 16. Now, I have variables on both sides and non-variable terms on both sides. So what I'm going to want to do is get rid of a variable term on one side. And I'm going to do it onto the right side because 4b is less than 6b. So I'm going to create a zero pair here. All that's left over here is going to be 2b minus 12 equals 16. I then want to get rid of this minus 12. So in order to do that, I'm going to add 12 to both sides. And I'm left with 2b equals 28. Last step, of course, is going to be getting b all by itself. So in dividing by 2, we get b equals 14. It does say to check your solution, so what I'm going to do is I'm going to rewrite this equation. So 6, I have b minus 2. And over on the right side, I have 2, and then 2b plus 8. B, it says, is 14, so I'm going to substitute 14 in wherever B is. And start simplifying. So, parentheses first, 14 minus 2 is 12. And 6 times 12 is 72. On the right side of here, I have 2 times 14, which is 28, plus 8, which is going to be 36. So I have 2 times 36. And 2 times 36 is also 72. So that checks out. Alright, so now that we've gotten a little bit of review on dealing with that, we have some different options here now as far as what our answers could look like. Because every single time we've had some kind of equation or inequality, we've had it where it's a variable equals a number. But that's not always the case. So let's go ahead and start kind of figuring out what kind of cases we could have. And in fact, there are 3 of them. So I'm going to separate this into 3 columns. So I'm going to make them just a little bit bigger here. To give some examples and what they should look like. So this first type of solution is one that we're used to. That means we have one solution. Now when we're looking at this one kind of solution, what your answers are going to kind of look like are going to be something like this. where we have a variable equaling some number. So like x equals 3. B equals -7. W equals 0. Things like that. Now, there are two other types of solutions. One of the solutions that we could also have is something called all solutions, or sometimes we also call it an identity. Now, in this case, we would have a variable or a number equal to itself. So, for example, we could have x equals x, 3 equals 3, -7 equals -7, 0 equals 0. Let's say q equals q. Those are ways that we could have all solutions, or an identity set. Because in this case, whatever we substitute in here for x will always be the same thing over here. So if we say that x is 7, 7 equals 7, that's true. Let's say that x is 400, 400 equals 400, that's also true. And then contrasting that, we could also have no solutions. And sometimes we call this a null set. And in this case, it's going to be a number equal to a different number. So for example, 3 equals 4. That's not true, ever. -7 equals +7. Also not true, ever. 400 equaling 1. Also not true. This is going to be no solutions, or something called a null set. So let's give some problems here, some examples. Solve each equation. So the first thing we want to do is simplify. So this would be 3 times 4x minus 3 times 2 plus 15 equals 12x plus 9. Now, 3 times 4x is 12x. 3 times 2 is 6, so I'm going to subtract 6, add 15, equaling 12x plus 9. Right here, I have like terms, so I want to combine those. A -6 and a plus 15 will get me a plus 9. And I'm not sure if you can see this yet or not, but on the left side, we have 12x plus 9. On the right side, we have 12x plus 9. Those are exactly the same, which means this is going to be an all solutions or an identity. But if you don't see that yet, let's keep moving. So we want to get rid of the variable term on one side. So let's say I'm going to subtract 12x to create a 0 pair. I'm left with 9. And on this side, all my x's are also creating a 0 pair, so I'm left with 9 also. Now I'm left with the same number on both sides, a number equaling itself. This is all solutions or identity. Both are going to be appropriate answers. Letter B. Simplify on the right now. So I'm going to leave 7y minus 8 alone. On the right side, we have 3 times 2y. Plus, we have 3 times 4. And plus y. 3 times 2y is 6y. I'm going to leave 7y minus 8 alone. So 6y plus 12 plus y. Here and here are like terms, so I'm going to combine those. 6y and y makes 7y. So I have 7y minus 8 equals 7y plus 12. And again, I'm not sure if you can see this yet or not, but both sides have a 7y, and this has a minus 8 and a plus 12. This was going to be a null set and no solutions. But if you don't see it yet, let's continue. So I'm going to take 7y and I subtract 7y to both sides. This creates a 0 pair, I'm left with just 12. This also creates a 0 pair, and I'm left with just negative 8. These are not the same number. So what we would say is this is a null set and no solution. All right, let's look at our next example here now.